experiment is implementing a simple multi-layer perceptron using NumPy and Pandas library. The experiment demonstrates the training process of an MLP for a basic binary classification task and evaluates its performance on some test data. Program implementation. The program begins by importing necessary libraries such as NumPy, Pandas, and Matplotlib. Then it defines the necessary functions for forward, backward, and prediction using sigmoid activation function. The MLP architecture consists of an input layer with 2 neurons, a hidden layer with 2 neurons, and an output layer with 1 neuron. Weight matrices W1 and W2 are initialized with random values. The training loops runs for a fixed number of iterations during which forward propagation, backward propagation, and weight updates occurs. Loss values are recorded for each iteration. After training, the program defines a prediction function to predict outputs for given test inputs. Execution and results. The program is executed and the loss curve is plotted against the number of epochs. The loss decreases over epochs, indicating the model is learning. Finally, the program predicts outputs for different test inputs, such as 00, 01, 10, 11. These are binary inputs for two values and prints the inputs along with their corresponding predicted values. Now, let's understand how to code an MLP architecture. Here we import the necessary libraries NumPy for numerical computations and Matplotlib for plotting. We initialize our input data X and corresponding output labels Y. Then we define the architecture of our neural network, including the number of input and output neurons, the number of neurons in the hidden layer, and the number of training examples. Additionally, we set the learning rate for gradient descent. Later, we do weight initialization. We initialize the weight matrices W1 and W2 with random values. These weights will be updated during the training process to minimize the loss function. Now, the sigmoid function introduces nonlinearity into the network and squashes the output between 0 and 1. For forward propagation, we define the forward propagation function that computes the activations of the hidden and output layers given the input data and the current weights. For backward propagation, the function calculates the gradients of the loss function with respect to the weights using the chain rule and propagates in backward direction through the network. The iterations and the training loop. Iterations, loss functions are given in this process. In this loop, we iterate a fixed number of times. For example, in our case, we have mentioned as 10,000. In each iteration, we perform forward propagation to compute the output and loss, then backward propagation to compute the gradients, and finally update the weights using gradient descent. Now, plotting. We plot the losses and we get the visualized plot through Matplotlib. Let's predict a few values. This code predicts the output for each set case and prints the input along with its predicted values. As you have seen, we've got an output table. Now let's understand the applications of MLP. Pattern recognition. MLPs can be used for pattern recognition tasks such as image classification, speech recognition, and natural language processing. Regression analysis. MLPs can also be used for regression analysis such as predicting housing prices, stock prices, or any continuous value prediction problem. Anomaly detection. MLPs can be used to detect anomalies in data by learning normal patterns and flagging deviations from them. Recommendation systems. MLPs are used in recommendation systems to predict user preferences based on historical data. Financial forecasting. MLPs can be employed to predict financial trends, stock market environments, movements, and risk assessment. Healthcare. MLPs can assist in medical diagnosis, predicting diseases, outcomes, and analyzing medical images. Through this video, we have understood what is an MLP, how to program MLP, and what are its applications.